first Quideo problem presents us with a data set of the salaries of various small business CEOs in thousands of dollars. So what the problem is asking us to do with the data is to construct a histogram and then write a paragraph or a statement which describes the shape, center, and spread, as well as whether or not there are outliers. So those are your basic SOCs. So the first thing that you should do when constructing a histogram is to decide what size intervals you will be using. So to do that, first you have to get an idea of the range. So we can see here our smallest number is 21, that being $21,000, and our largest appears to be 1,103. So using the fact that you want to have between 5 and 7 bars on your histogram as a guideline, I split the data into equal intervals of 200, and I made this chart right here, and I simply went through and counted up how many occur between 0 and 199. Well, that's 6. How many between 200 and 399? 32. And I graphed the data above here. So for my histogram, I labeled the y-axis as the frequency and the x-axis as the salary in thousands of dollars. That's an important step, is making sure your axes are labeled so the person viewing the histogram actually knows what data we're talking about here. The next part of the problem, as I said earlier, was to go ahead and write a paragraph describing the SOCs of the data. So I pretty much did exactly that right here. I said the shape of the histogram displaying salary frequency of 59 small business CEOs is skewed right. So that is describing the shape. We can tell that it's skewed right because well, you can see it levels off down on the right side, and we have a large quantity of data over there on the left. Note that I also included what it was we were talking about. So we're talking about the salaries of CEOs. So that's important to include so the person reading knows exactly what it is that you're saying. I next went to the spread. So I'd say the minimum is 21 and the maximum is 1,103. In thousands of dollars. I actually skipped this, but I also included the median. So the median of the data set is 350. So right off the bat, I've included the shape, the center, the spread, which I elaborate on further, giving the 2 quartiles, and then I go in and say there are no apparent outliers, because as you can see, the data takes on a fairly regular skewed right shape. There don't appear to be any large outliers. So that pretty much answered the question. We created the histogram, we broke up the data into intervals, we labeled our axes, and then we described the SOCs of the data. So that pretty much sums up the first question for Quideo 1. So the second problem on Quideo number 1 gives us a various data points about chest measurements of 5,738 Scottish militiamen. This was recorded in 1864. So they give us a table this time of frequencies rather than just various data points like in the first problem. So part A asks us to make a histogram. So like I said earlier, the first thing you need to do is decide what size intervals are we going to be using. So we see that the sizes range from 33 to 48. So again, if you want to have between 5 and 7 bars on your histogram, it might be a good idea to break those into pieces of 3, which will, I believe, leave you with 6 bars. And so I went ahead and did that and made a chart here. And all I did was, so for example, for the first interval, 33 through 35, I just added up the total counts from those on there. I did that for each group of 3, and it gave me the this data right here. The next thing you do is actually make your histogram. So I again did that, labeling the axes, the chest size in inches, very important to include units. And then it gave the count over there on the left. So we can see that the data is taken on an approximately normal shape right off the bat. The next thing it asks us to do is describe the shape, center, and spread. So pretty much going through socks again. And then to think about, why might this information be useful in the first place? Why did these people in 1864 record these chest measurements? So talking about the shape, as I said before, it's pretty apparent that it is approximately normal. So and again, make sure you include what exactly you're talking about. So I say the shape of the histogram displaying in inches the chest size of Scottish militiamen is approximately normal. So the person reading this actually knows what data we're referring to. I go in to say there don't appear to be any outliers, which is quite apparent if you look at the graph or even look at the data. There's really not a very wide range. I give the mean, okay, because when your data is approximately normal, your measure of center should be the mean, and your measure of spread the standard deviation, rather than the median and 5-number summary, which you would expect when working with any other form of data, whether that be skewed left or skewed right. So I've pretty much summed up the summary of the distribution, described any patterns. So then we go into, why might this information have been useful? And I guess this is definitely something that's up to interpretation, but what made sense to me and what I included was that, this might have been used when thinking about how to make the uniforms for these militiamen. I'm assuming that they were mass-produced in some form, so having an idea of, how big these people were, what kind of range is there on their the size of their chest, that might be useful and very relevant information when you're making thousands and thousands of shirts. You want to make sure you get that right. So that pretty much answers the second question. One small thing which I didn't include in the first part of this is exactly how you get the mean and standard deviation, which are the relevant measures of spread and center for this data collection. And once you've determined that it's approximately normal and that those are appropriate, you go into your calculator and you actually create 2 lists. One list with the chest sizes and another with the counts. And it's as simple as going into calculating one variable statistics. Your first list is the list of the actual sizes, and then the next is your frequency list, which is then the counts that we see here. So once you calculate those, if I actually had data in there, it would reveal the mean and standard deviation. The third and final question on the Quideo, which is an AP question, presents us with a series of box plots taken from different rivers. So it says that the Department of Agriculture was trying to clean up various sites, River X, River Y, and River Z, because they had become contaminated. And so they measured the presence of a chemical called aldrin, which is a pesticide, at 20 different locations throughout the different rivers. And these are the box plots here. So we see that the x-axis is our concentration, and the y-axis is, well, those are just explaining what the different box plots are for comparison. So we know that they have 20 different data points for each river. So the first part asks us to compare the distributions of the concentration among the 3 rivers. So when it's asking us to compare 2 data sets, to me, it seems like that is asking us to compare socks. So compare, what do their shapes look like compared to each other? What does their spread look like? So I just wrote here a paragraph kind of comparing all the basic points, which I can kind of just go over right here. The first thing we might look at is the shape, and they all appear to have very different shapes. I'd say River X is skewed to the right, as there's a higher concentration of data over on the left side. River Y, it seems like it's approximately normal. The quartiles look like they're about the same. And for River Z, it looks like it is slightly skewed to the left, with a higher data concentration on the right. For their centers, the center of X and Y look like they are about the same, and they are both higher than the median of River Z. So when doing a comparison of distributions, it's important that you directly use comparison words like this is larger than this is larger than this, these are about the same, rather than just giving the different values. So I start off by saying that the median for River X and Y are about equal, and they are both larger than the median of River Z. I'd say the shape of River X is skewed right, whereas the shape of River Y is approximately normal, and the shape for River Z is skewed left. So I'm comparing X, well, it's different than these two because the reasons stated. None of them have outliers, so that is one component which they all share in common. And then finally, looking at the spreads, it looks like River X has a larger range and interquartile range than both the other ones, and that Y has a larger one than Z. So X appears to be the most spread out of the distributions given. So that's a fairly adequate comparison. The next part is asking us, it's giving us actually the specific data which was used to construct the box plot for River X, and it's asking us to make a stem plot. Well, a stem plot, as you know, just has the ones place or the tens place or whatever the largest place is on one side, and then the other, the decimals in this case, on the other side. So if we start out just looking at the range of the data, it appears to go from about 3.4 up to 8.6 approximately. So if we just start out labeling our stems going from 3 to 8, and then filling in the leaves, that gives us an idea of the shape, which kind of confirms what we had thought before, which is that it is skewed to the right, because if you turn it like this, well, we see there's more data on the left than on the right. So we know that that is skewed to the right. And so that it just gives us a general idea of the shape as well as the specific values which make it up. So that part is not too complicated, just asking us to make a stem plot. The next part asks us to describe a characteristic of the distribution that you can see on the stem plot but not on the box plot. And so what strikes me as apparent on this that you can't see on this is that there's actually a hole at 6. There are no data points here with the concentration of 6. So there is a hole there, which is relevant information to include, but it's information that you couldn't find from the box plot alone. So I merely just state that one characteristic is that there's a hole. So that is the final part, and that sums up Quideo number 1.